Okay, so here basically are the main types. There's not a ton of them. So the good news is you'll know from a small subset what types are possible. Okay? So let's discuss each of these. We're going to look at integer, float, character, string, and Boolean. And these should ring a small bell from the lab yesterday. These data types are generally available in any language. Okay? The nomenclature, or the way you declare it, might be slightly different. Okay? It might be a slight spelling difference or something like that. In Java and C++, most of these are similar. So when you know you need an integer, you just have to find, okay, I need an integer. How do I declare it in this language? Okay? The idea of it being an integer is universal to all languages. Does that make sense? So we're learning the general details about data types. The specific details is how you actually declare it in a particular language. But once you understand the general details, you'll be able to use any language at all. Okay, so one of the main types of data that we use is numerical. We use these in calculations. We use these for counting things. We use these for operations. We use it for things like salary and hours. We tend to do a lot of mathematical things that use numbers, okay, particularly with the use of computer, because we want to have a lot of numbers. We want to crunch them accurately, and we want to do it quickly, okay? When we have a numeric type, we tend to choose one of two types. We choose integer or real. Integer or real. These keywords that are listed here are the particular keywords in the language that indicate whether something is integer or real. Okay? So let's talk math. What is an integer number? Integer number is a whole number. And it can also be what? Positive or negative. Positive or negative. Are most people, you may not have used the term integer, but everybody understands the concept of a whole number. Okay? Everybody understands a whole. So in computer science, we refer to this concept as an integer number, okay? As the integer data type. When we declare something to be integer, we use the type int in C++. The same thing is true for Java. So given the guide that I gave you for declaring a variable, if it's type name semicolon, this line right here declares a variable named what? Num1. The type of the variable is integer. So what happens when I have this line of code in my program? What happens? Num1 is allocated, space for the variable is allocated in memory. Does everybody see that? So behind the scenes, num1 is given a location in memory. It's also going to only accept integer values. What does that mean again? Whole numbers. Whole numbers. Okay? So no decimals. All right? Only whole numbers. Now, what would be unique about picking an integer? Can you give me some example? Do I have it up here, actually? Well, one of the main places where we use whole numbers is when we're counting something. Why is integer appropriate for counters? Why is integer appropriate for counters? Jared? Okay, age is another example. Yes, age is another example where we use whole numbers. Okay? Teresa? Yeah, okay, so if I'm counting people or boxes or cars, I typically use a whole number. I don't say I have 3.5. Sometimes I feel like I have a half a student when they're sleeping at 9:30 in the morning. But they are typically, we use a whole number to count the number of individuals, okay? So this is why the integer data type makes the most sense. So for counts, an integer is a good choice. Does that make sense? He's also correct that age, we typically use an integer. Can anybody think of anything else where we might use an integer? Not sure this is easy to think of. Anything else we might use an integer? Some math, yeah. Okay, so counting the number of days, and or yeah, the date. If you want to say month, day, year, those are all integer values. We talked about feet. We had a couple of other examples yesterday. If you give your height feet is always an integer, right? Adam, another example? Yeah, so some mathematical requirements only when you work with whole numbers, okay? So there are some cases where an integer is appropriate, okay? Now notice one thing. In my declarations, one of the guidelines for making your programs more secure is to do a separate declaration on each line. It is actually legal in C++ to say int num1, comma, num2, comma, num_students. However, we've been advised by security experts to teach students to do it this way. It'll just make your programs more secure and ensure that the types are firmly established. So even though this is not a rule, it's a convention to help us towards that idea of making programming our programs more securely. Okay? So separate declaration per line. Question?
When you're declaring something, there's like a short versus an integer. Would the short be more secure to keep buffer overflows from that?
Okay, that's an excellent question. So in the textbook, which I'm happy to see a lot of you reading, it mentions a few other data types before int. In actuality, in C++, there are 3 separate data types for int. And I bet based on the name, you can guess what these are. One of the data types is called short. One of the data types is called int. And one of the data types is called long. What do you think let me write these up here. What do you think the difference, and we're actually going to do a lab, which I've temporarily removed because I'm updating it, on this very fact. What do you think the difference is between short, int, and long? Okay, less. Okay, Jared, do you want to add to that?
Short, you can actually have only smaller numbers. It gives you a smaller range of numbers than you can have inside the values. And it's kind of a medium size as long as a large number over billions.
Okay, so the deal is with C is that you don't really know whether you're default to short or long. There's really 2 types, short and long. And if you say int, you're not guaranteed whether it's going to be a short or a long. It depends upon the compiler. Okay? So one of the exercises we'll run in lab is we'll actually find out how much space is being allocated when we do a short, int, or long. Okay? But here's what I want you to get. When I declare a variable, let's say I declare a variable to be int num1, a certain amount of space is allocated. Well, how do we measure that space? How do we measure this space here? And we measure it in bits, bits, okay? So let's say that 32 bits, which is a typical int, is stored for an integer, which is typical, okay? So we have 32 bits of storage if we say int num1. So what's the largest number that can fit into num1? You don't have to tell me the number, but how would we kind of know what the largest number would be? Of? Of? What would be in here? Yes. Well, the largest would be all these guys were 1s, right? The largest would be all those guys are 1s. And I'm going to get to show you what that value is, and we'll think about when we have to be concerned about the size. And I think we started to talk about that a little bit on Tuesday. I want to go into a little more detail at that at the end. I want to make sure I cover everything today. Okay? But 32 bits is fine for most applications. It may not be fine if you're doing world population. Okay? And in that case, instead of choosing int, what should you choose? Long. Now, should you always choose the largest size? Wouldn't that be easier? But what's wrong with that? It's what? Brianna? Well, it's not less secure, but it's wasteful of storage. We typically only store as much space as we need. I mean, that's the programmer's, kind of paradox. Don't, have as much as you need, but not more than you need. You know what I mean? You want efficiency and security are all things that we have to consider. Okay? Question? Okay, so this is integer overflow. Okay, and so what could happen is if I put a number that was too large in here, which is very possible, that it would cause an integer overflow, and what happens is it wraps around. The computer does not, we're actually going to do this in lab. It does not crash. What happens is that the number becomes a negative because it hits this sign bit, which we talked briefly about the other day, and you get incorrect data, which is almost worse than crashing because you have no idea it's happening. So you just have data that is inexplicable, you have no idea it happened. So it's a very dangerous, insidious error. Okay? So yes, integers are prone to these types of problems, and that's why we have to think about the size a little bit. Okay. All right, now I'm going to get more into this because I love talking about this. Whoops, shoot. But let's make sure we cover all our types first. The second numeric type is for real numbers. And of course, this has many more applications, right? Because integers are whole numbers, but real numbers are what? Decimal. So there's lots and lots and lots of guys that include decimal. Give me an example. Give me an example of where I would use a decimal value for some type of application. Jeremy? Weight, if you want to have your weight in half pounds or even, even further, like if you're weighing a package and you want to have a very precise value for the weight, weight could be float or real. It could also sometimes be integer, but definitely could be float. Temperature, typically, Justin, temperature typically, especially for body temperature, because that's 98.6. So this would be a place where you would use a float. Other examples of where you would use float. Why can't I see your name? Okay. Annalika? Okay, what? Sorry? Shoe size. I like it. Okay. Shoe size. 9.5. Okay, prices. I'm surprised you guys didn't say this first. Anything with money is almost always decimal, right? $350, $465, $592.76. You can't do any kind of dollar values without floats, okay? Speed of, like, let's see. Okay, so I typically, if I'm going 62, I guess it could be 62.5. You know what I mean? Could be, yeah. Distance, how many miles? A lot of times you see on Google Maps, they say 102.6 miles, so yeah. Rate, like a tax rate, sales tip rate, yeah. So what do we get the idea here? That there's a few things that use integers. Almost everything else uses float, okay? So what are our types for this? Well, we have two options. We have float or double. And here's what happens. In C++, we tend to always use float. I don't know why. Well, I think actually I know why that. In Java, we tend to always use double, which is bigger. So that would be my question. So for some reason or other, we have different conventions in both those languages. So float gives us so what happens if I declare a price to be if I have price 1 as float and price 2 as double, what do you think the difference is for price 1 and for price 2? Jeremy? It's going to have more storage, probably twice as much. So one might have 32, one might have 64, depending upon the compiler. So a float value allocates, let's say, 32 bits. A double value allocates, let's say, 64 bits. Okay, now, before we leave this, I want you to think about how something is stored. So let's say that I declared, count to be int. And here's my memory map. All right, so now, let's put our thinking caps on here. If I now say count equals 7, what happens at that memory location? Good. 111, because we remember that 111 is 7, and a bunch of zeros go into count. Does everybody understand that? Okay? All right? So And to say, what we're saying is the binary equivalent of 7 is stored at the memory location called count. That's all that's happening. Okay? All righty. What happens when I say price 1 equals $10.50? Ideas? Okay. Yeah?
It would put the equivalent for binary as on a decimal point.
Well, now keep in mind the equivalent for a decimal point would probably be like take 8 bits to do that. So here's how it happens, because I don't think you'd know otherwise. Scientific notation. Who remembers? Okay? So if I wanted to put 1050 in scientific notation, isn't that 1.05 times 10 to the 1? Something like that? Do I have that right? 1.05 times 10 to the 1, so this guy goes over 1. Okay? So in that value, we have something called the mantissa, and we have something called the exponent. And what would happen for price is both of these would be represented in binary. So the 105, no decimal, would be encoded into binary, and the exponent of 1 would be encoded into binary. This is a lot harder to actually look at the code and understand what's happening. Here's what I want you to get out of this. Okay, because we can't really look at, I guess you could. It's much more difficult to look at a memory location and try to determine the float number. Hey, but here's what I want you to understand. If I have too big a number for count, what did we say happened? It wraps around. It's an integer error. Okay? And if I give myself more storage for an integer, what does that allow me to do? Put larger numbers. On the other hand, with float, if I have more storage, it gives me more precision. So what do I mean by that? So let's ask something else again. Which do you think takes up more storage? The number 1 million or the number 0.236745? The decimal. Why? Why does the smaller decimal number take up more space than 1 million? There's more digits of precision. Okay? So typically, for floating point, when I allocate more space, such as double, that allows me to do more digits of precision. Does that make sense? It's not always larger numbers, but to have more precision. So if I'm doing something that requires a lot of precision, such as military trajectories, let's be very precise on that, then I would want to have a very large, to have a double as opposed to a float, so it stores more precision. Does that make sense? Okay. We should always, the rule of thumb is we don't just randomly say, oh, it's easier to use doubles, it's easier to use longs. We want to only use as much as we need. That's basically part of our challenge of efficiency. So we've learned three different types now. And I basically, when I get a numeric value, I now pick a name, I pick a type, whether it's whole or a real number, and I choose whether it's integer, and I choose whether it's real or float. Okay? And this would be how I would declare these variables. Okay? Everybody with me? So that's pretty straightforward. Okay? Now, before we move on to the next, what about something like zip code or social security number? Yeah. Yes. Why should that be string? Exactly. So one rule of thumb in computer science, some numeric values such as telephone number, social security number, zip code, these are better to use the string, which we're going to talk about in a second, as opposed to the integer value. Because we're not going to add them or subtract them. A zip code might begin with a 0, which I want to show up, right? So for these values, for these types of values, we typically pick string, which I'm going to talk about next.